Dear students, in the last session, we discussed about the electrolysis. Electrolysis given by molten NaCl, electrolysis given by aqueous NaCl. We discussed discharge potential theory also. But based on that concept, how the questions will be framed, we're trying to discuss some of the questions based on this concept. The first question is here, the gas that gets liberated at the cathode of the electrolytic cell, the gas that gets liberated at the cathode of the electrolytic cell. So that's why in this one, we used one word that is electrolytic cell. So generally electrolysis is given by which cell here it is device used for electrolysis. Electrolysis is called a electrolytic cell. So that's why here device used for electrolysis known as the electrolytic cell. But which gas is liberated at the cathode? They did not give any information about this question. Simply they mentioned at the cathode. That's why generally we have to know one information. So what is that here? At cathode, what is liberated? At cathode, anode, what is liberated? We have to know. That's why here, in general, for any electrolysis, at cathode, only hydrogen gas is liberated, or we can say that is metals will be deposited. Metals will be deposited at the cathode. So observe the point very clearly. At the cathode, hydrogen gas is liberated, or metals can be deposited at the cathode only. Then at anode, what reaction is given here? So at anode, this reaction is given, means which compounds? Generally, metals means nothing but what here it is, they are electropositive. That's why here, electropositive elements can be produced or liberated or deposited at the cathode. And come to the anode, here it is. Simply here we can take non-metal elements. Non-metal elements can be liberated at the anode of electrolysis. Any electrolysis here it is. Non-metal elements. So that's why here non-metal elements can be liberated at the anode of any electrolysis solution generally. Okay, that's why here we can take non-metal elements. Non-metal elements okay, here non-metal elements means nothing but what here it is, they are electronegative. That's why electronegative elements can be formed or liberated at the anode, and electropositive elements can be liberated at the cathode. This is here the information. Then you can see the second question, among the following ion, which ion will get easily discharged at anode? Among the following ion, which ion will get easily discharged at anode here? They gave the four ions, sulfate ion, bromate ion, nitrate ion, and hydroxide ion. Sulfate means what the formula we can write here, it is SO4 minus 2. Bromide means we can take it is here the Br minus, and nitrate means here it is SO4 minus 1, and OH minus here it is. So according to what is the hint or a hint of this question here it is, that is here, according to discharge potential theory. According to discharge potential theory, the ion which is having the lowest discharge potential that involves in the reaction that discharges at the anode here, which is having lowest discharge potential value. So that's why we are taking order of dp value of anions here it is. That's why here it is F minus and SO4 minus 2. Next one NO3 minus, and next one we can take that is here OH minus, next Cl minus, Br minus, and I minus here it is. So this is the order of dp value of anions is given here. So which is having the lowest dp value? Br minus. That's why here Br minus involves in the reaction. Br minus loses the charge at the anode here. That's why what is the answer of this one here? Second option, that is Br minus, that is bromide ion discharges at the anode easily than with comparing other ions. That's why what the concept of this one, according to discharge potential theory, This is the order of dp value of anions here. Lowest dp value, highest involving in the reaction. The next one we can take here, that is the third question. So what is the third question of this one? Here it is. Dash electrodes are used during the electrolysis of acidulated water. Here it is. Dash electrodes. That's why here dash electrodes are used during the electrolysis of acidulated water. Here it is. Acidulated water. So acidulated water means what are the electrodes? First of all, here it is. So iron is given. Next one, platinum, manganese, and here carbon, that is graphite we can take. So that's why here, which electrodes are used for the electrolysis of acidulated water? Acidulated water means here nothing but what here it is. Acid with water, here it is H2SO4 plus water. So that's why for this electrolysis, here the platinum electrode means inert electrode. That's why here this platinum inert electrode used as the electrode in the electrolysis of acidulated water. So we'll discuss this concept by next question also. And before that, we are taking other question. What is that here? So that is here, silica crucible used for electrolysis of which compound? So before that, I'm removing this completely. Here it is. So that is here the fourth question. Silica. What is the question here? It is silica crucible. Okay, that is a silica crucible used for electrolysis of So they gave the four option, that is here in this one PBr2, and second one here we can take PBr2 and aqueous NaCl. Next one acid water, that is acidulated water, and next one here molten NaCl. So they gave the four options of this one. What is the answer for this one? Here it is. So silica crucible is used for electrolysis of which are the following compound here? That's why here the answer of this one is PBr2. So why it is here the PBr2? We have to discuss. Okay, that's why here I'm explaining a explanation of this question here. It is. So what is the explanation here? It is. So the explanation is given like this here. First of all, we have to take the crucible. Why we are using the crucible silica only in this process here? That's why I'm taking a crucible of silica here, and it is filled with PBr2. PBr2, that is here molten PBr2 is taken. Molten PBr2 is taken here, and then here after that arranging with the electrodes here. But in this one here, which electrodes are used? That is here graphite electrodes are used for this one. So both are the graphites only here. This is the anode, this is the cathode. Here anode and cathode are used, which are graphite electrodes here. And then we are taking molten NaCl PBr2. Here it is molten PBr2 is taken, but it is heated slowly. What is the melting point of PBr2? That is here 380 degrees centigrade. So 380 degrees centigrade. To maintain the 380 degrees centigrade, this crucible is heated. This crucible is heated slowly. Then the PBr2 converts into molten state. That's why to maintain the molten state of PBr2, the crucible is slowly heated. And that's why here it is, by using the crucible, silica crucible in the electrolysis of PBr. But what ions are produced in the electrolysis? We have to know completely process of this one here. PBr2 is taken, here it is. Converting into which ion here? Pb plus 2. and Br minus. Then cation, anion. We know already cation moves toward the cathode side, anion moves toward the anode side. That's why here at anode, what reaction takes place? At cathode, what reaction takes place? That's why here at anode, here it is. At anode, which ions are moving here? It is Br minus. That's by converting into Br to gas. Converting into Br to gas, here it is. That's why here Br2 gas is liberated. Bromine gas is liberated here. But what is the color of this one here? It is dark reddish brown fumes are liberated at anode here. That's why dark reddish brown, dark reddish brown fumes are liberated at the anode. That's why if these fumes are liberated means we should understood bromine gas is liberated at the anode here. But at cathode, what reaction is given here? That's why I'm writing here it is at cathode. So at cathode, what reaction is given here? Cations gains electrons. Generally, gaining of electron means something, but what we can take reduction process. That's why here gaining the electron converting into Pb solid. That's why here which one here it is silvery gray. Here silvery gray solid is deposited means here we should understood the Pb is deposited at the electrode, that is here the cathode here. Then the overall reaction of this one we can understand like this here. PBr2 liquid means nothing but molten state converting into Pb solid and Br2 gas. Pb solid and Br2 gas. This is here the electrolysis of this one here. So in this one, why we are maintaining here it is silica, here it is silica is having the high silica can maintain the high temperature also. At high temperature also does not changes its physical state, and silica is slowly heated to maintain the molten state of PBr2. Okay, that's why it does not involve in the reaction. This is the reason to use the silica crucible for this process. And this is about which one here. So based on this one, we can create the number of questions. What are the questions here? It is why here reason why silica used. Okay, why silica is used for electrolysis. Electrolysis of PBr2. Okay, this is a one question. And question formation is very important. The next one, how many electrons involved in the process? How many electrons? That's why here, how many electrons involved in the process? Here it is involved in a process. Here it is. That is how many electrons we know that is here 2 electrons. Okay, 2 electrons are involved. In this one, the gas, color of gas liberated, color of gas liberated at anode. Color of gas liberated at anode. That is here also one question. And color of solid deposited, color of solid deposited at the cathode here. Cathode in this electrolysis process. That's why here, like this, we can make the number of questions based on this one also. This is here the way for the electrolysis of the PBr2. This is question to answer method. And then we are moving to the next question about this one in the same electrolysis here. That is here question number 5. So that is here, what is the ratio of hydrogen to oxygen gases liberated at the electrode by volume? What is the ratio of hydrogen to oxygen gases liberated at electrodes by volume during electrolysis of acidulated water. So acidylated water here, that is the question. So in this one, they gave the four options, that is here 1:1, and next one 2:1, and the next one 3:2, and the next one here it is 1:2. That is here what the ratio of hydrogen to oxygen gas is liberated at the electrode by volume during the electrolysis. That's why here in this one the answer of this one is here 2:1 ratio. But how it is, we have to discuss completely. So that's why here I'm explaining the explanation for the electrolysis of acidylated water. So then what is here the explanation for electrolysis of acidylated water? That's why I'm taking here the two, okay, here two test tube like operators here, that is in this one, these two are connected, and here both are filled with acidylated water. Okay, here acidylated water. This is also filled here, and but this is arranged with electrode here from bottom, and this is also arranged with electrode that is here the bottom here it is. But what electrodes are used in this case here? The electrodes used here, that is platinum electrode. This is here the platinum electrode. This is also platinum electrode, and connected with which one here? That. Generally, our concept is what here? This is given anode, and this is given cathode. And in this one, acidylated water means what here we are taking? That is here H2SO4 plus H2O. But in the solution, what type of ions are present here? In the solution, which ions are present? The H plus ions are given by water, OH minus ions are given by water, and H plus ions are given by H2SO4, and SO4 minus 2 ions are given by H2SO4. Means these three ions are present in the solution. H plus ions are given by both water and H2SO4. The next one, particles present in the solution. What type of particles are present? This is only ions, but we can take the particles H plus, OH minus, and SO4 minus 2. Along with that, water also present. Means here, the total water does not decompose into ions. It can produce the equilibrium. Okay, that's why here, some of the water molecule present in undissociated form. That's why total number of particles in this one is a 4. Total number of types of ions is here the 3. Then here in this one, what reaction occurs at anode and what reaction occurs at a cathode, we have to know. That's why here at anode what reaction is given here. But in this one, how many types of anions are there? Two types of anions. One is OH minus, one is SO4 minus 2. But which ion involves in the reaction? That is OH minus ions only involves in the reaction. So why it is here? Two types of ions are there, but OH minus only involves in the reaction. Where it is here at anode, means in this condition. And that's why here OH minus involves in the reaction, here it is. But what is the reason? dP value of OH minus is lower than the SO4 minus 2. We told this point number of times. And that's why here it converting into H2O gas, H2O, and losing the electron. How many electrons are lost here? It is 4 electron. And which gas is liberated here? It is O2 gas is liberated. That's why we can take 4 OH minus ions converting into, here it is 2H2O and 1 mole of O2 gas. That's why 1 volume of O2 gas is liberated. This is here at a anode here. But at a cathode, what reaction is given? At cathode, what reaction is given? Here it is. That's why here, in this one, how many types of cations are there? Only one type, because both the compounds are giving same type of H plus ion. And that's why here, H plus ion gains the electron. But how many electrons are lost by the anion here? 4. That's why 4 electrons are gained. And that's why 4H plus involves in the reaction. That's why 2H2O is a form. That's why how many volumes of O2 H2 gas is liberated here? 2 volumes of H2 gas is liberated. That's why this is only the answer. For the ratio of H2 to O2 gas liberated at the electrode by volume during the electrolysis of acidylated water. That's why 2:1 means 2 volumes of H2 gas, 1 volume of O2 gas is liberated in the electrolysis process. And that's why here, finally, what we can write the overall reaction. Here, H2O involves in the reaction, converting into which two gas here, which gas here, H2 and the O2 here it is. This is here the overall reaction. This is electrolysis of acidylated water. But in this one here, at anode of acidity, so H2SO4 is present. So that's why at anode, acidity of solution increases. At a cathode, acidity of solution decreases. So that's why here at anode, acidity of a solution increases. Solution increases. Acidity of solution increases. But at cathode, acidity of solution decreases. At cathode, acidity of solution, which one here? Decreases. What is the reason? Come to this one here it is. This is the anode. So at anode, what reaction is given? OH minus means the count of OH minus decreases in this part. Count of OH minus decreases. That's why more water molecule converts into OH minus and H plus, means H plus ion concentration increases. And here H plus ion concentration increases means what here it is? The acidic nature, acidity of the solution increases here, because OH minus decreases means H plus ion increases. That's why acidity at the anode increases, but acidity at the cathode decreases. At cathode, which ions involves here? H plus ions involves. That's why here count of H plus ion decreases. That's why acidic nature or acidity of solution decreases at the cathode. Acidity of solution increases at the anode. This is the reason. But based on this one, how many types of questions will be framed? We already told one point here in the last one, that is the question number 3 here. What electrodes are used? What electrodes are used in the electrolysis? So what electrodes are used in electrolysis of the acidylated water? And number of electrons involved in the process. How many electrons involved in this one? 4 electrons involved in this one. And number of OH minus involved. How many number of OH minus involved here it is? Okay, 4 OH minus. And number of H plus ions involved in the process. So that is here 4 H plus. And the next one, acidity of solution at anode. Acidity of solution at anode. What is here? Decreases or increases? That is the question. Increases. And acidity of solution at a cathode. Acidity of solution at a cathode increases or decreases. We have to. So like this, we can make the questions based on this one. This is complete concept of the electrolysis of acidylated water here. So this is here the electrolysis. Based on electrolysis, some question formations, and I explained how the questions will be framed. Okay, based on one concept. So this is here the electrolysis process with the question formations. And the remaining part we'll discuss by next session. And thank you.